Hello everyone, my name is Ashley Goodnight and this is my Reading Week 6 video. The main concept of this week was momentum. Momentum, represented by the letter P, is equivalent to the object's mass times its velocity. This week, we dealt with the cases of non-constant velocity, where there are three main cases. The object can be speeding up, slowing down, or reversing in direction. All of these can only occur if delta P and delta V are non-zero quantities. We can decompose the change in momentum over the change in time, delta P divided by delta T, into two components. Its parallel component is responsible for speeding up and slowing down the object. Its perpendicular component is responsible for the curviness or changes in direction. Just as we decomposed the change in momentum over time, we can estimate the derivative of momentum. This approximation can become pretty accurate assuming delta T is relatively small. Following these steps on the slide, we can break down the derivative of momentum into similar parallel and perpendicular components. Another topic we discussed this week was black holes. Specifically, we have now learned enough to hopefully solve for the mass of a black hole. In order to do this, we look at the forces from the motion. First, we identify the entire system. Next, we find the net force. Then, we specify the interactions. The last step is solving for our unknown, the mass. We make the general assumption that only one force, gravity, is acting on our system. Using Newton's law of gravitation, we can find the estimated value for the mass of the black hole. In my previous experience with physics, I learned the equation for centripetal acceleration. When you plug it into Newton's second law, multiplying mass times acceleration, you find an equation for centripetal force. What I did not previously know was that the centripetal force isn't real. It's a change in motion from the change in momentum over the change in time that points towards the center of the kissing circle. Speaking of the kissing circle, I had a difficult time understanding what it was. I looked up this article from PLUS magazine, which explained that another way of thinking about curvature is to approximate the curve at a particular point with a circle. This circle, called the osculating circle or kissing circle, just touches the curve at that point and has the same curvature as the curve there. This entire article by PLUS magazine really boosted my understanding. This week's physics is useful and has its application in my major, electrical engineering. One of the threads that Georgia Tech allows EE majors to pursue is signal and information processing. This is a branch of electrical engineering that models and analyzes data representations of physical events. We tackled this very same concept when back solving for velocity, momentum, and force based on the observed motion changes over time. With that, I am concluding my presentation. Thank you everyone for listening. See you all next week.